Okay, so picture this. You take a huge, powerful piece of tech, I'm talking room-sized, and you shrink it down so small it fits in a backpack. Well, that's exactly what we're digging into today. It's this incredible, silent breakthrough, and it all starts with a very, very special laser.
Just think about it for a second. What kind of new discoveries could we make? What problems could we finally solve if our most important scientific tools weren't stuck in a lab? I mean, if they could go anywhere in the world. That's really the big question we're tackling here. So to really get why this is such a big deal, we gotta start with a problem. What were they even trying to fix? And it all comes down to this one super important type of laser that, for the longest time, has basically been a prisoner of the laboratory.
Yeah, we're not talking about the little red laser pointer you use for presentations. Not even close. We're talking about something called excimer lasers. These things produce this really powerful, specialized deep UV light. And this light is an absolute workhorse in all sorts of fields, from science and environmental monitoring all the way to industrial manufacturing. It lets people do incredibly precise work, at a microscopic level. So, here's the catch, right? The central problem. On one side, you have these incredibly useful lasers, but on the other, they've got this one huge drawback. They need these massive, loud, vibrating mechanical pumps just to circulate gas. And that makes them super bulky and pretty much impossible to take out of the lab. So they're stuck, even though they could be doing so much good out in the field.
All right, so how do you fix a problem that's all about big, clunky, moving parts? Well, the answer turned out to be pretty brilliant. You just get rid of them completely. The researchers came up with this really radical new idea, a pump with zero moving parts. None.
It's called an Electrohydrodynamics pump, or EHD pump for short. And this is where it gets really cool. Instead of using fans or pistons or anything physical to move the gas, it uses a powerful electric field to do all the work. And think about what that means. No moving parts means no noise, no vibration, and a way smaller size.
Okay, so how does this magic actually work? Well, you've got this grid of tiny little needles, and they create what's called a corona discharge. All that really means is it gives the gas molecules a little electric zap, a tiny charge. And once they're charged, a powerful electric field can literally grab onto them and push them along. What you get is this perfectly steady, totally silent, vibration-free flow. It's just such an elegant fix for a clunky mechanical problem. So once they ditched that old mechanical pump, the results were, well, they were transformative. I mean, the team was able to pack a ton of power into this ridiculously small package. I mean, just look at that. The whole system is now about the size of a thermos, the kind you take coffee in. We're going from something that could take up a big chunk of a room to something you can literally hold in your hands. This isn't just an improvement, it's a total game changer. But, okay, it's small, but is it powerful? Oh yeah, for sure. Even with no moving parts, this EHD pump got the gas moving at 1.27 meters per second. That's more than enough speed for some serious high-performance work. And that fast-moving gas, that translates directly into power. We're talking pulse energies over 2 millijoules. Now that might not sound like a lot, but for a deep UV laser, especially one this tiny, that is a ton of power. And maybe the most important part? It's incredibly stable. The energy output barely wavered. We're talking a relative standard deviation of just 1%. And if you're doing any kind of sensitive science or industrial work, that kind of rock-solid consistency is everything. It's absolutely essential. Okay, so let's recap. They've got a small, powerful, stable laser. Mission accomplished, right? A huge success. But this is where the story takes a really interesting turn. Because while they were testing this thing, they stumbled onto something completely unexpected. A scientific mystery hiding right inside their own invention. They found that under just the right conditions, the laser's power would just spike, suddenly and dramatically. It wasn't a gradual increase, it was what they called an explosive transition, a huge instant burst of energy. So the question was, what in the world was causing it? So they dove into the complex chemistry happening inside the laser, and they figured it out. Turns out, once the conditions inside hit this very specific threshold, it sets off a chain reaction, a cascade. And that results in this sudden, massive flood of photons, the actual particles of light. They basically discovered a brand new microscopic process that has a real-world effect on how the laser works.
a really fundamental discovery in laser physics.
All right, so finding a mysterious energy surge is one thing, but actually controlling it, that's a whole different ballgame. And to turn this unpredictable quirk from a bug into a feature, the team reached for a really powerful modern tool, AI.
They built something called an interpretable machine learning model. And that word interpretable is super important here. The goal wasn't just to make some black box AI that could predict the spikes. No, they wanted to build an AI that could actually understand them, an AI that could spot the patterns in the chaos and tell them why a surge was about to happen. And you know what? It worked. The model was a huge success. It can nail the predictions for these energy surges under all kinds of different conditions. And the key takeaway here is that this AI gives them the ability to actually optimize and control the laser. It turns what could have been a problem into a feature they can actually manage and even use.
So where does that leave us? What does it all mean? Well, we've got a tiny, powerful, super stable laser that we now understand and control better than ever. And that means XMR lasers are finally free. They've been unchained from the lab.
And that just blows the doors open to a whole new world of possibilities. I mean, think about it. We could use these for real-time environmental monitoring out in the field, or for exploring the deep ocean. You could mount them on drones, or even use them as portable tools for on-site industrial work. These are all things that were basically science fiction before now.
You know, this whole story is just such a great reminder that sometimes the biggest breakthroughs aren't about making things bigger, but about making them smarter, and a whole lot smaller. It really leaves you with a fascinating question, doesn't it? We have a laser that fits in a thermos. So what other giant technologies are out there just waiting for that one brilliant idea that'll finally set them free?